Transmission line. First, what do we mean by a transmission line? Then primary parameters and secondary parameters in traveling reflected waves. Introduction to a transmission line. So what do we mean by a transmission line? It can be electric power line of kilometers, length of kilometers, or it can be a microstrip of PCB, printed circuit board, which is centimeters or millimeters. It can be optical fiber or balanced line like here, or coaxial cable like here. And any of these transmission lines is, obviously we assume that these lines are actually uniform lines, and each of them is characterized, first of all, by length, kilometers, meters, centimeters, and so on, and then by primary parameters, per unit length parameters, inductance, capacitance, resistance, and conductance. Per unit length, per meter, Henry, Farad, Ohm, or Siemens per meter. So we may express our line as a connection, cascade connection of two ports of this character. Infinity of these two ports are connected in cascade. And this is our transmission line. We are interested in line equations. So we start with this segment. The length of this segment is delta x, where delta x is going to 0. From Kirchhoff's voltage laws and also element equations for this two-port segment of line, we obtain this so-called line of telegraphist equation, because why telegraphist? Many years ago, simply a transmission line was a telegraph line. It was no PCB. And these are equations. Obviously, I skip the reasoning. I skip all these derivations. These are, and obviously, there is no sense to learn by heart. Sorry, once again, I have forgotten to switch to Flamaster. So obviously, it is no sense to learn by heart these equations. We will never use them anyway. From these equations, I will just show you the way of reasoning up to the final stage, which is waveforms, voltage and current waveforms at the distance of x from line input. This is our task, to find these equations, starting from these equations, telegraphist equations, and also we have equations of our source and our load, Ohm's law. It is quite complicated. The mathematics behind this derivation is quite complicated, and I will skip all these derivations. I will only show you the final result and also some parameters, the so-called secondary parameters that will appear. These parameters are denoted here in red: characteristic impedance, propagation constant, refraction coefficients. So at first we transform these equations into Laplace domain, then after some mathematics, which is quite complicated, we obtain waveforms in Laplace domain. Once again, these equations are quite complex, quite complicated, and finally then after transformation, inverse transformation, we may obtain traveling waves in time domain. Why traveling waves? It will be explained later on. So I will skip all this reasoning. As you see, it is quite complex story, quite complex. We obtain, during this reasoning, we obtain a characteristic impedance, and I'm afraid you should learn this by heart. We obtain a secondary parameters. Secondary parameters, primary parameters are per unit length parameters. Here are secondary parameters that are functions of these primary parameters, and they are Laplace domain functions. And you have them expressed here in this frame. Then we may find the waveforms. And these waveforms, believe me, it is not very difficult to learn by heart how these waveforms are created, to write them down, the equations. But I will explain this to you in the lecture. At this stage of explanation, I only want to concentrate that we have two kinds of waves, obviously voltage and current waveform. And within a voltage waveform, we have forward traveling waves and backward traveling waves. We have these so-called reflected waves, traveling waves. So after we have a transient state, a source is switched on, DC source, for example, then we have some wave traveling from the line input to the line output, then we have a reflected wave from line output to the line input, once again reflected, and so on, until the steady state condition is reached. But this will be explained later on only for special cases, because for general case it is nearly impossible to give the equations for special cases for lossless line first of all. But it will be explained in the lecture. For now on, that's all.